Hello, our developers. Today we are going to learn about the Ola Zero Knowledge Proof language and how to use it to develop an Ola Smart Contract. An Ola Smart Contract is a new type of zero knowledge proof language that can be deployed on Ola VM. Today we will learn how to write a contract with it and then how to compile it. First, we open VS Code. Because the Ola team has developed a plugin that can be used for writing in VS Code, we can start by creating a new project. Today we will use a voting contract to show developers how to write smart contract with Ola. Okay, let's get started. First, we create a folder, for example, called voting contract. Then we use VS Code to open it. Alright, we have now opened this voting contract with VS Code. We can start by creating a voting contract, just called voting contract. Okay, at this moment, we haven't installed VS Code plugin yet. There are no syntax hints or anything. And this file doesn't have any icon. The system default is just a text file. We need to find the Ola plugin in the VS Code extension repository. Okay, the first one is Ola syntax plugin. We can install it. We have successfully installed the VS Code plugin. You should probably restart it. Okay, VS Code have refreshed and can now detect the presence of this plugin. Now let's write a smart contract. Ola's syntax is actually very similar to Solidity's. Ola official team has developed many examples for users to refer to. For specific syntax, we can refer to the Ola-lang repository and then a README. We can click this link to go to Ola-lang explanation page. We can look at some specifics through the quick start. Instructions for compilers installation are adopted for each operating system. Following the steps, you can install Ola compiler for all operating systems. This subsection displays some of Ola's syntax which we can examine. For Ola, we can see its syntax is quite extensive. It includes basic filters like tab declaration, text scoops, data tabs, basic tabs, and field tabs. Field tabs is specific to the zk field, along with full address, hash tabs, and some composite tabs, complex data tabs like arrays, strings, and structs. Below are some usage instructions for these tabs. Tab alias is supported. You can define a tab and rename it to another type, including supported contracts. These are some of the operators supported by its type system, some of which are very common and can be found in other languages. Ola's syntax is actually very similar to Solidity and Rust. Its functions declaration is similar to Solidity's and also resembles Rust function signatures. These are some core libraries developers can use to build high-performance applications, including things like caller address and origin address, which can access current blockchain-related state information like chain ID, etc. These are its common sense features yet to be implemented. We can look at some of its examples. Here is a Fibonacci sequence example. You can see that this Fibonacci sequence is very simple. Its implementation is straightforward, supporting both recursive and non-recursive approaches. Below is a contract for person, which defines an enumeration type, a structure, and through master you can see its syntax. It's very concise, creating a person and then storing the person into blockchain's global state. Then here you can retrieve a person ID and person age. Ola-lang also supports cross-contract calling, similar to Solidity, calling from one contract to another. These are two ways. One is delegate call and the other is a regular call. The difference between delegate call and call is similar to Solidity. One supports changing the current execution address state and the other changes the caller execution process state. This is the calling contract for cross-contract calling. This is the API documentation for the Ola-lang. For example, a contract like this one for a book, it can be compiled by Ola's compiler to produce the corresponding API. This way, we can construct contract call transactions in SDK using these APIs, and we can clearly understand the return values and parameter types of these transactions. This is a detailed explanation of Ola compiler. We don't need to delve into this much details for the contract. This is the syntax design of the Ola-lang. We don't need to understand this part either. These are some appendix. You can refer to them later if needed. Well, we need to focus on Ola-lang documentation and examples. We need to refer to these examples to write some contracts. Besides this, we can also refer to some examples in the example direction of its official repository. In the source, there are many pre-written contracts. For instance, there is already a template for the voting contract we are developing today. There are some contracts with import and the like. We can refer to them to implement our own business function contracts. There are also some contracts related to blockchain DD interactions and on-chain state, all of which can be found here. Alright, let's continue to look at the voting contract we want to implement today. When we input con and press enter, we can get a basic framework for the contract. We can name it proposal here. For a proposal voting contract, it should have some structures to save it proposal information. We can create some proposal info. We hope to have the proposer's info in the proposal, so we can use an address tab to save the info of the proposal initiator. The current proposal also needs to have corresponding deadline info. We can use the user duty to record its deadline info. Similarly, we can record the current vote support info. We can also note some details about the current opposition votes. Our proposal also has specific tabs. We can create info for proposal tab. First, we create an enumeration for proposal tabs, representing proposal tab info. Okay, let's assume we have these proposals. We also need some info on the voting tabs. We need simple voting and also the weighted voting. For simple voting, each proposal simple vote means adding 1 to the vote count. If it's weighted voting, the current vote count is increased by weight. We also need to record the voting and proposal info. Similarly, we need a mapping to record the specific content hash and its relationship to the proposal. We can use the hashtag for mapping. Next, after writing the aforementioned basic data structures, we can create some method for voting. We also need to include the content hash. And also a deadline. We need to obtain the current transaction initiator's address. That's it, the current proposal's initiator is the transaction initiator's address. Here, unlike Solidity, we need to use an origin address to get the address initiating the proposal. Okay, we have finished creating a function for proposal creation. As we can see, to create a proposal, we need 4 parameters: a hash tab for a content hash, deadline, proposal tab, and voting tab. Then we created a structure for a proposal and fill these parameters into it. Finally, we store this mapping relationship into mapping. Thus, the proposal is stored in the mapping. Next, we perform voting for this proposal, and voting also requires knowing which content to vote for, also requiring a hash for the vote. We need to know whether it's a vote for or against. Next, we need weight information. We need to ensure that the proposal's time is actually less than the current time step. For this, we don't need to use if, we can use assert. Ola's assert function is somewhat similar to Solidity's require. We can use assert to implement this better. In Ola, we need to use block time step to get the current time step. If it's equal voting, we first create a variable for weight to save it. If it's the current voting tab, equal with voting, we then use 1 as the vote count. If it's not equal with voting, we consider vote count to be the past weight. Here we add amount. After updating the current information, we need to put it back into current mapping to update our blockchain word state. This way, the voting contract still needs another function to fetch the current proposal information based on the content hash. We can write a function like this to retrieve the current proposal information. By inputting the content hash, we will return the structure of the proposal. Here we need to add parentheses for the return of the proposal. Ola supports multiple return values, so we can add parentheses to make a clear distinction. We can see our voting contract is now complete. The voting contract has 3 functions in total: creating a proposal, voting, and retrieving detailed information on the proposal. We can see it's very convenient to write contracts for business functionalities. This also uses 2 Ola-specific system level functions, namely origin address and block time step. Here are some differences from Solidity. For specific differences, we can refer to the documentation on system libraries, which lists some internal functions supported by Ola. We can find the corresponding documentation here. Alright, that's it for today's introduction to the use of Ola's plugin and Ola-related syntax. Let's conclude here. We welcome developers to use Ola-lang to write smart contracts on Ola platform. Thank you, everyone.